driving can be a dangerous proposition, and traction is the key to increased safety. Fortunately, the best traction control systems coupled with all-wheel drive can greatly increase safety when things get slick. Some recent internet videos showed a group of vehicles climbing a ramp made with rollers. The idea was to eliminate traction from 3 of the vehicle's wheels and show which systems could transmit power to the wheels that still had traction and those that couldn't. When Toyota engineers saw that video, they asked us at AMCI Testing how their all-wheel drive Venza with active torque control would fare against a comparable Subaru Outback, but in the harshest real-world conditions, glare ice. As background, it's important to know that we test more than 150 vehicles a year for most of the major manufacturers, so we have to remain truthful and impartial. To start, we insisted on procuring our own brand new Venza and Outback blindly from local dealerships. And to take the driver out of it, and to show Venza's ability to completely manage the situation on its own, consistent measured throttle will be applied and held during each sequence. In this most difficult test, we'll measure the time it takes for each vehicle to travel 50 feet. A small amount of wheel spin as it hunts for nearly non-existent traction, and both vehicles cross the finish line essentially together, separated by a scant 5/100ths of a second. In this second test, we'll keep 3 wheels on ice, but give the left front tire unlimited traction with this metal plate. The challenge will be for each vehicle to channel as much torque as possible to that single wheel with traction, then drive the car forward. In spite of their technical differences, both vehicles successfully moved the 5 feet in almost identical elapsed times, 1.28 seconds for the Outback, and a slightly quicker 1.23 seconds for the Venza. When we move the traction plate from the left front position to the left rear, the vehicles take about 1/10 of a second longer, with the margin still in favor of the Venza. In another real-world scenario, we'll put the rear 2 wheels on ice and give both front wheels traction. Their performance is separated by a scant 1/100th of a second. And when you move the traction to the rear axle and put the front on ice, the results are again identical. George Deganis is AMCI Testing's lead test engineer. George, how can this be so close? Both of these cars have completely different all-wheel drive systems, even different wheel sizes. Break it down for us.
You're right, it's a fascinating result. What this tells me is that the engineering teams of both companies set out with the same goal: to get all they can out of these tires, to get all the available grip out of these tires. There are 2 different systems, different approaches, but the end result is the same. They both got every ounce of grip that these tires can offer.
Next, we explore differences in how each vehicle handles variations in traction side to side. We'll keep the ice on one side of the car, simulating ice at the curb or maybe glare ice where a snowplow has partially cleared a lane. Both vehicles leave the line with a slight hesitation, but here too, they are separated by a mere 5/100ths of a second, this time in Outback's favor. Our conclusions? First, in automotive testing, results are only valid predictors of real-world performance when the tests are conducted in real-world conditions. And second, although there may be defining differences between the Toyota Venza and Subaru Outback, all-wheel drive performance on ice is not one of them. In the worst winter conditions, both vehicles performed admirably, in spite of the differences in their engineering approaches.